So we're going to start. My name is Sivia Van Gundy. John invited us to speak. We were originally scheduled to speak at the end of February at this meetup in Mountain View. But as we all know what happened at the end of February, and some of us weren't able to travel. And so we're very grateful that we could do this remotely, because I'm located in Placerville, California, and Josh and Drew are located in Frederick, Maryland. And so I'm going to turn this over to Drew to do a brief introduction to Fugue and to Josh.
Great. Thanks, Sivia. And hi, everybody. Appreciate you having us out. I think this is going to be a really kind of fun and interesting and sometimes maybe a little scary presentation that Josh is going to deliver. So stay tuned for that. I'm Drew Wright, one of the co-founders at Fugue. And what Fugue is all about is putting engineers in command of cloud security. Developers, engineers are building their own cloud infrastructure environments. They're updating them continuously. And we feel that engineers really kind of own the security of their cloud infrastructure. It can't be something that a separate security team is really responsible for, or a compliance team. But rather than that kind of being like, oh no, we've got another responsibility, it's actually a good thing, because the cloud is 100% software. And cloud security is really all about getting the configuration of all of your cloud resources secure and correct, and making sure that they stay that way. And so what that means really, because it's software, it's a software engineering problem. Cloud security is not kind of that traditional security analysis problem. The fact is a lot of the exploits that we see in the cloud don't really traverse traditional networks. Traditional security analysis tools just kind of can't catch them even after the fact. So the way to get this right is by using tools like policy as code and continuous monitoring of the entire configuration state of your environment, to find things that are wrong before the malicious actors can find them. So essentially what Fugue does is a couple things. First, gives developers and engineers a really easy way to validate their cloud environments, say a dev environment that you're working on, you're developing an application, next version of the application, quickly get feedback on where you have compliance violations for a number of kind of out-of-the-box compliance standards. You can use your own, apply your own enterprise kind of custom policies using OPA, the Open Policy Agent, which is an open source standard for policy as code. And things like the Fugue best practices, which will, the Fugue best practices framework will find some misconfiguration risks that the compliance standards are not going to catch. So you get kind of quick feedback on where those policy violations are and how to fix them. And once you've got it where you need to go, you obviously can deploy to production. You can use Fugue to kind of catch things at deployment time to kind of prevent introducing misconfiguration into your environment. But once you have your production environment, Fugue kind of continues to keep an eye on it. It can produce any number of compliance reports for you that you can kind of automatically have shipped off to whoever needs those. So kind of get away from manual audits and validations of your cloud configurations. Kind of automating everything using policy as code, we feel, is the way to kind of ensure that your cloud infrastructure is safe and that you can prove that compliance of your cloud environment at any time to anybody who needs it. So it kind of just makes your life easier, and I think helps people sleep a little bit better at night. It is a SaaS application. It takes about 15 minutes to get up and running and get a full near real-time visualization of your cloud environment, and apply any number of compliance regimes to that environment to kind of find out where you need to focus your remediation efforts. We have a free forever plan for individual developers to use Fugue. It's the developer plan. If you go to fugue.co/go, you can get registered and get started. And again, about 15 minutes, you're really up and running with Fugue. It's pretty quick time to value. So with that, I'm going to turn it over to my co-founder, Josh Stella, who is going to kind of get his hands on the keyboard and walk through a pretty neat and scary advanced misconfiguration exploit. So thanks, everybody.
Thank you, Drew. Thank you, Sylvia. And thank you, John, for hosting us. So hi, everyone. I'm Josh. I co-founded Fugue with Drew. And tonight, Drew gave you a little bit of explanation of what we do as a company. But what I'm going to do is show you some real world cloud exploits in real time. The agenda for the evening is going to be, I'm going to go through some slides to explain what cloud misconfiguration is and what the risk is from it. But then it's going to be a lot of hands-on keyboard at the terminal. If you're not super technical, I'm going to go slow and really explain what I'm doing. If you are technical, that's great. And feel free to reach out via the chat. When I'm in the thick of like doing the demo, maybe Drew or Sylvia will interrupt me if you throw something in the chat, but feel free to interrupt at any time. And to make things a little bit more fun, I'm going to change my Zoom background from my home office to different things from the history of computing and anime and gaming, like, you know, the stuff I'm into anyway. And if you're the first person in the chat to name what my background is, you're going to get a cool t-shirt. We have these Fugue t-shirts and a coffee mug and I think something else, but you'll get some swag. We figure folks want swag and there are no trade shows to go to right now. So we're going to try to keep it fun. And with that, I'm going to throw up the first background before I go into my, well, John got the first background. He already got a swag pack for this one, which was Next Step in Mathematica. But I'm going to switch gears and go to something from anime. Okay, I'm going to share my screen and go through some slides. So let's just share this whole desktop. I'm going to leave. Drew, are you seeing my desktop?
Yes, indeed.
Okay, cool. I'm just going to leave it in this mode rather than going to full screen mode. So what we're doing today is a live simulation of a cloud misconfiguration attack. I'm going to go over a little bit about cloud misconfiguration risk, what it is, why you should care about it. Then we're going to spend most of our time doing a live demonstration. We've got a pretty good block of time today. So we should be able to go into detail, and feel free to interrupt me with questions or what have you. Then we're going to get into some actionable steps to secure your cloud environment. So how do you prevent these bad things from happening to you? So to begin, what is cloud misconfiguration? Well, it's a major security risk. And this is from Neil McDonald at Gartner. Nearly all successful attacks on cloud services are the result of customer misconfiguration, mismanagement, and mistakes. So prior to founding Fugue with Drew, I was at AWS, primarily working in national security kinds of environments. And I saw this all the time. And I obviously, after leaving AWS and founding Fugue, I see this all the time. This sounds pretty kind of accusatory to, oh, I think someone stopped my screen share.
Sorry, I was trying to, it was John. Please share again.
Okay, I can do that. Sure, no problem.
I clicked something.
All right, am I back on the slide?
Yes.
Cool, cool. This sounds pretty accusatory, like, you know, why don't people get cloud security right? Well, the answer is it's really hard because these cloud APIs are quite complex. So the figure on the right, 93%, comes from a survey we did at Fugue, what, a year and a half ago or so. And we asked 300 or so, organizations that are operating at scale on the cloud, a number of questions. And one of those was, are you concerned about having a major security breach due to misconfiguration? And 93% said they were, which is encouraging to me. The 7% are probably the ones that are being breached right now. But 93% is a pretty good number. Everyone should be concerned about this. It is extraordinarily difficult to constantly be aware of whether or not you are vulnerable to attacks via misconfiguration. So we also asked in that survey what kinds of misconfiguration folks were concerned with. And the largest single category, and obviously these are not exclusive because they add up to quite a bit more than 100, was identity and access management. And I was surprised that people replied with this, but I was very pleased because they're right. Identity and access management in the cloud is closer to a network. I think Ishan got it. I hope I'm not mispronouncing your name, but you are correct, sir. This is the background contest. This is Neon Genesis Evangelion. I'm going to go a few more slides before I put the next background up because, and I'm going to tell you, we did this a few weeks ago in the DC area, and they got every one of them, usually within like a minute or two. So I'm not trying to be competitive here, but I expect Silicon Valley to do at least as well as DC on nerd culture stuff. But congrats, you're exactly correct. Ishan, I won't say your last name because I don't know if this is private names or not, but Drew or Sivia will reach out to you and we'll get you a pack. So the first thing people were worried about is identity and access management. And you will see as I demonstrate tonight why that is such a major concern. So the second, security group rules, absolutely spot on. These things, if you get them wrong, you are really exposed to bad guys getting at your stuff, exfiltrating data, stealing data, or doing other bad things. Interestingly, the third one is object storage access policies. So when you read the news about cloud breaches, it's always about like an insecure S3 bucket, right? But that's only a piece of the story, and our respondents to this survey understood that rather. Yes, you need to be very concerned about your access policies to object storage. But as I will demonstrate later, you can have good access policies to object storage, and via IAM vulnerabilities and security group vulnerabilities, bad guys can still steal your data. And that is usually what's happening, the story behind the story. And then finally, of course, encryption. So just a few weeks ago, given everything that's going on in the world, I mean, we do these surveys with some frequency. Ishan, you're welcome. I hope you enjoy it. He said thank you in the chat. So we do these surveys with some frequency. And the most recent one we did was just a few weeks ago. So we get asked questions of folks about what they're concerned around, distributed workforces, which we are all experiencing more of. And how that has affected their cloud security posture. So we asked, is your team transitioning to 100% distributed? And 83% of our respondents, and these are respondents who are, doing sizable workloads on cloud. So that is the kind of selection criteria. 83% are now making the transition to 100% distributed teams, and 84% are concerned about cloud security during that transition. So when we see these high numbers, I'm encouraged. You know, my background, when I was at AWS, I was focused on Department of Defense and intelligence kinds of workloads. And so my background is kind of split between the high tech industry and the national security world. And I'm actually gratified to see how much people are worried and insecure about their cloud security posture, because they're right to be. Okay. Yeah, this misconfiguration is a major security risk. This is from the latest survey results we have. Cloud misconfigurations around, you know, have you been hacked and don't know it? 84% are concerned. That is a good concern to have. In one of the major breaches last year, it went unnoticed by a major financial institution for months until the attacker bragged about it on social media. So it is, I believe, it's impossible to prove, right? But I believe that many cloud breaches go completely unnoticed until something, you know, hits the news or someone is, shaken down, essentially. 92% concerned for vulnerability to a major cloud data breach. Again, I'm encouraged that people understand how vulnerable they are, because then hopefully they take these things quite seriously. And in the next year, do you think cloud misconfiguration risk will increase or stay the same? 76% said increase. I believe they are correct. So cloud misconfiguration is often overlooked for different reasons. Many cloud misconfigurations, many dangerous misconfigurations, are not recognized as misconfigurations or as dangerous by security teams because, in part, they're not considered policy violations by compliance frameworks like NIST or PCI or SOC or CIS. A lot of the attack vectors the bad guys use are not handled by those things. And so the security team will say, this looks good to me, because they're going by industry standard guidance, right? That's a reasonable thing. But that industry standard guidance is way behind the bad guys. And so it is exceedingly common in enterprise cloud environments. And by the way, I'm not trying to drag on cloud here. I have a very, very high opinion of AWS, of Microsoft, of Google for their security measures and what you can accomplish with security on these clouds. It's not that they're producing insecure platforms. It's that the folks who use them aren't aware of all the ways bad guys can exploit misconfigurations to steal data. And what that means is these things are very, very common, I would say, perhaps universal in enterprise cloud environments. All right, a little bit about hacker strategy. We've got this as before cloud and cloud. I mean, it's more like, 10 years ago and now, and that's coincident with cloud. I'm not sure how much those are related, but the change is very real. So if you think about, your kind of classic Hollywood hacker movie, it's the old school way. And this still happens. It happens with some frequency. But I'm going to get to how most of these things happen now. So kind of in the old days, the bad guy would target an organization. And the kind of recent, well, not even that recent, but some well-known examples might be things like the North Koreans targeting Sony because they didn't like a motion picture they made. Or who knows who targeting the Iranian nuclear weapons program with Stuxnet, right? So in the old school way of doing hacking, you would pick an organization and then you would search for vulnerabilities to exploit. Okay, I'm going to switch my background here because I think I've gone on long enough. I'm going to choose another background so we can get another winner. Okay, you have to identify what computer this is, and I'm going to move my head to show the telltale sign of this. if you get really close in the ballpark, you'll win. I know we're talking to folks in Silicon Valley. I will tell you that this computer is actually in the Computer History Museum in San Jose. So that's a hint.
We are seeing your presentation, not your background.
Oh no, hold on. Let me stop screen sharing for a second.
There
so you can see this
go.
background. All right, and that's the giveaway right there. So if anyone can tell us what this is, you'll win some swag. It's not ENIAC. No, it's not ENIAC. But good try. All right, I'm going to. Boy, this is
Josh,
awkward. I was hoping my my background would show while I was showing. No, it's not an IBM 360. No, you're getting closer. Actually, where were they based? I think a Boston company. The very first
yes, they were.
computer game ever released was written on this actual computer. Univac. Nope, it's not from Unisys. All right, well, I think I've given folks some time on that. I'm going to keep moving on. And if you come up with it, let us know. Maybe I've gone too far back in the day. Okay, so before cloud, in the old days, the bad guys would target an individual organization, and then they would try to find exploits into that organization. The way this is done much more commonly now is the bad guys are running bots. They're running automated scripts that are looking for misconfigurations they can exploit on any IP address that's public. And this often happens within seconds or minutes of a resource going online publicly. There's this, if you think about having like a known catalog of things you can use to attack a system, and then just looking at any IP address that comes online, and if they have those vulnerabilities, cataloging them, it creates a shopping list for bad guys to go and attack those resources that are misconfigured and exposed to risk. So number one is identify misconfiguration vulnerabilities in an automated way. And number two, then prioritize the target organizations. This is how most of the breaches we're seeing today, including very, very high profile ones, are happening. And what that means is the bad actors are automating, so you have to automate too to keep up with them. And the good news in cloud is you can do that. In the data center, that was nearly impossible. So before cloud, the network and security teams, it looks like we've got some chats coming in here. Oh, AJ, that's the PDP one. That's it. Oh, it was James first. I'm sorry. Oh, well, it looks like Civi is on it. We got 3 winners in short order. So HS, James, and AJ all got PDP 1. Space War was the first video game. It had a light pen. How cool is that for the early 1960s? You could draw on the screen. So before cloud, the network and security teams would build infrastructure. They would populate the data center, and then the application teams would install their applications into that infrastructure. And that created a scenario where the infrastructure and security teams had the opportunity to make sure things were, pretty well secured. Decades of breaches proving that not perfectly secured, but pretty well secured. In the cloud world, the application developers create their own infrastructure, right? When you stand up a system in the cloud, you're not pushing it into some server that was requisitioned 6 months ago. You're probably instantiating new containers, new EC2 instances, new Lambda functions, new databases as a part of building that application. And that means, and this is all automated through APIs. And that means it happens really fast, and it's constantly in motion. And therefore, you need things like policy as code validation tools to prevent that misconfiguration, and then also to automate the detection and remediation of those configurations. Okay, I'm going to walk the tightrope here. I'm going to go off video while I'm typing, but I promise to come back and give you more chances to win a little bit of swag. I'm going off video because it's kind of awkward to be typing at a console while a camera's pointed at you. So please forgive me that. Okay, first I'm going to explain what I'm going to be doing. So this is a diagram that our product Fugue creates. This is not a Fugue product demonstration. I'm going to be hacking infrastructure, but it's helpful to show you this visualization to see what I'm actually going to do as I break in and steal data. So over on the left here is the internet. There is a VPC network here with a compute instance, a virtual machine, inside of it. And as you can see, its name is I've got a CVE. This is a compute instance. It could also be a container that has a known vulnerability. So when I was talking before about how bad guys are automating their attacks, they're looking for things like this. Once I get into this, there's not really a lot for me to do in a single compute instance. What I want is to steal data in this case. I mean, usually hackers are doing kind of one of two or three things. The top two are stealing data, number one, and two, crypto mining on your dime. And in the breach that I am simulating here, the bad guy actually did both, according to the Department of Justice filings. But in this case, I want to jump from this EC2 instance, and I want to get into S3. S3, we read about in the news all the time, how people steal data out of it. Well, often it is more complex than just finding an insecure S3 bucket. So here, I'm going to get into this EC2 instance, and then I'm going to try to jump over to this attractive looking important records S3 bucket and steal its data. Okay? So let's simulate doing this. Now, I said in this diagram, you know, this EC2 instance has a CVE. That's a common vulnerability. It is a known risk, right? Probably due to things like operating system patch levels or misconfigured security groups. Now, I'm not going to run actual malware against that. I'm not going to run hacking tools against that because AWS might notice that I'm doing that and shut down my AWS account in the middle of a demo. And this is a live demo. This is live fire stuff here. So if I mess up, please forgive me a little bit. Instead, I'm going to pretend like I used an exploit just to get shell on that box. Not root. I don't need any special permissions. I just need shell. So all I did here was SSH into this EC2 instance. Okay. And you can see right away that there are 13 packages needed for security. This is how a lot of folks get hacked. There's something sitting out there, you know, in their cloud environment that they've forgotten about. If I select this EC2 instance, you know, it might have been running for a very long time and I might have forgotten to patch it. By the way, the visualization I'm showing and all these details, you can get for free from us, for free forever in the developer version of Fugue for relatively small environments. So please, you know, check it out and tell us what you think. But I've just shelled into this box. And since I'm a bad guy that wants to steal data, I see here it's Amazon Linux, which is a perfectly good distro, but I know that Amazon Linux has the AWS command line tools installed. So I'm going to try doing something. I'm going to use the AWS command line. So I type AWS, and then I'm going to target S3, and I'm going to ask for a list of S3 buckets. Now, a lot of folks think the list permissions on services are not that dangerous. They're extraordinarily dangerous. You should not grant them in your production environments. So in this case, our AWS administrators have done a good job, right? Our cloud team have done a good job. I got an access denied. That means they understood that giving that EC2 instance permission to list S3 buckets was dangerous. So how does the EC2 instance have permissions one way or another? It is through what's called an IAM role association, which is done through an instance profile. So over here, you can see I've selected that EC2 instance. It is, a lot of folks don't understand this about cloud. In the cloud, the identity is not just for the user, it's for the components of the cloud. And so in this case, this EC2 server, this compute instance, is operating with the permissions of this thing called maintenance role. And maintenance role clearly doesn't have permission to do lists on S3. Okay, but I'm a tenacious bad guy. I got shell on your box, so I'm not going to give up so easily. I'm going to start poking around and looking at things like your metadata configurations. Going from Emacs copy paste to shell copy paste. Okay, so what I just did is a curl command. If you're not familiar with it, curl is kind of like when you type a URL into your web browser, like www.google.com or something like that. But it does it in the terminal and exchanges text information rather than graphically rendered web pages. So it's very commonly used when interacting with REST APIs. So in this case, I've gone to a special IP address, 169.254.169.254. And this is the infamous Metadata Service that all kinds of folks in the press got all worked up about being a problem. I'm here to tell you, as a security practitioner in the cloud for a decade now, the Metadata Service is awesome. If used properly, it is much better than the alternatives, generally speaking, but you should use it properly. What it is a web endpoint on the hypervisor, and you can think of the hypervisor as like the operating system above the virtual machines and containers that are running in the cloud. And that hypervisor has an understanding of the configuration of the things inside it, like compute instances. So here we're asking for the latest metadata. And you can see here, there are all kinds of data points in here, like the Amazon machine image, the host name, etc. What I'm interested in as a bad guy, now we were using Fugue a moment ago, so we already know this thing is running maintenance role, but as the bad guy, I don't have visibility to see that. So I need to do a query on the metadata IAM security credentials, and I see here that this EC2 instance has the role maintenance role. Now, this I think is a critical point. Bad guys are doing discovery, and that's how they steal your stuff. That's how they do bad things to you, is by doing discovery. Good guys rarely are aware of everything running in their cloud, which is why things like EC2 instances or containers hang out there and become vulnerable over time. So visibility and discoverability is absolutely critical. You want 100% visibility. That's why Fugue built this whole visualizer, and we've got lots of other views too. But what you want for anyone entering your cloud is 0% visibility, no ability to do discovery. And we just showed that because the configuration of S3 in the IAM role, IAM is what grants us permission or not to see S3, denied us that visibility, access denied. That's good. but I'm a clever bad guy and I'm going to find another path. But before I do that, I'm going to do another background. Let's see. Let's do this guy. This is actually highly apropos for what's going on right now in the video game world. So if you're a gamer, hopefully you'll pick up what I'm putting down here.
We're not seeing it, Josh.
Oh, let me stop my share again.
There you go.
So you can name the game or you can name the location. It's up to you. This is from the original. The new version just came out a few weeks ago. All right, I'm going to give it a sec here, and then I'm going to go back to sharing my screen. Hopefully folks have had a minute to take a look at that. Okay, so back to hacking in from this EC2 instance over to S3. We just established that I cannot see S3, but I'm a clever hacker and I know how these things work. So I'm going to start doing some exploration of some other things, and I'm going to start drilling in to IAM. I just saw that I have the maintenance role right now. Obviously, the maintenance role does not give me access to S3, but let's just take a look at the credentials for the maintenance role. So what I just did here is I said, give me a curl, go get from the hypervisor's metadata service, the latest metadata on the IAM security credentials for maintenance role. Now, this is what the press would have you believe is a disaster. I just got the access key, the secret access key. I've got all the keys to the kingdom, right? Terrifying. Actually, these are just the credentials that won't let me look at S3. So who cares? And if you're using the IAM metadata service for these data, these are going to be rotated at a fairly high frequency. You can see the expiration here. Right, we're talking about, a few hours. So this is not nearly as big a deal as people would make it out to be unless you use it in a naive way. So this is actually not my attack vector. I just showed it to you because the press likes to harp on it, and they don't really know what they're talking about. Instead, as a sophisticated bad guy, I'm going to go in a completely different direction. I'm going to use the AWS command again, but this time I'm going to query the IAM service, and I'm going to ask it to list policies. I'm going to ask for a list of IAM policies that I might be able to access. I'm hopeful that I have permission to do this. And then I'm going to do a grep, which is just a Unix search, for any policy name that contains S3. Okay, so I do have access to the IAM list policies in that maintenance role, IAM role. Now, you might be feeling a bit wrapped around the axle right now on everything that's going on in this IAM, bizarre scenario. Okay, yep, Ishan. Final Fantasy VII. Very good. So IAM is less like user credentials and more like a network in function in the cloud, because the resources, oops, I'm on the wrong screen there. The resources like this EC2 instance is only able to access things like S3 based on that IAM role. So you can think of it as more like a network, or even perhaps like an assertion in a firewall, than purely like the old school version of identity. So what I'm looking for here is another IAM policy that I might be able to adopt that will give me access to S3. And this S3 read-write looks pretty attractive to me. So the next step here, and this is kind of counterintuitive, and this is why we like to give these demos, is a lot of this stuff in cloud security is pretty esoteric. And you really have to understand deeply how these cloud resources interrelate. This is why people are worried about misconfiguration, because it's really easy to get unintended side effects and consequences from even very slight misconfigurations. So as a bad guy, what I'm going to do here, well, I could list some IAM policies. I saw one that looked attractive to me. I know, because this is my job as a, as a bad guy, to steal data, that the command I need to run to understand the IAM profile associations that I'm capable of asserting is actually not an IAM command. It is an EC2 command. So it's AWS EC2, and this gets really verbose, so I'm not going to expand it. Describe IAM instance profile associations. So this is going to enumerate for me the connections between the EC2 instances that I have and what IAM role they are associated with. So what I'm looking for here, this, by the way, looks like victory. If I'm a bad guy, I'm looking for that right there because I want to change that association. So I'm going to go over to another screen now, to my Emacs screen, and do some editing in a window because, well, you'll understand in a moment why. It's a very long command. Okay, it's a mouthful, but just walk with me here. It's not hard to understand. So AWS, I'm going to target EC2. Keep in mind, what I'm about to do does not require permissions deeply into IAM. It's an EC2 permission that I need. I'm going to replace the IAM instance profile association, very verbose command. This association ID, this is where I needed this guy, right? You can see it's in here now. I just copied and pasted that in my text editor. So I'm going to replace that instance profile association. So the instance profile association is how the EC2 instance is connected to its IAM permissions. And I'm going to replace that with the IAM instance profile whose name is S3 read write. Okay, that looks like victory right there. You could see up above, I was in maintenance role. And if you remember, maintenance role didn't allow me to see S3. But now the return message here from that API command is I'm S3 read write. Okay, I'm going to do one more screenshot here, one more background, since people have been picking these out pretty quick. All right, this one's kind of tough. And I'm going to stop my share.
And Josh, I just want to let people know too that if they've guessed one right, they may want to just hold off on guessing a second time because I may not be able to get 2 packages to you.
Yeah, you can only win once, people. Come on.
Right.
Oh, Kevin, you were right. I think you won it, but you're not right on the. It's the TARDIS, but this is the first Doctor. The first Doctor. So Kevin, I think you won it on the first line. Yep. Cool. Fourth Doctor is my favorite too, but this is from the first Doctor. Okay, I'm going to go back to screen sharing. The bubbles. Yes, Kevin, the bubbles. I agree. Well, I'm glad people are enjoying this. It's a lot of fun for me. Cool. So we just might have hit gold if we are a hacker trying to steal data. We now have this S3 read-write role. So I'm going to try again the AWS command S3 list. Now I get a list, an enumeration of all these buckets. I have hit pay dirt. And I hope this illustrates to you how dangerous things like list and describe calls are. If I were a bad guy, and by the way, these are goofy demo names, right? Like important records and customer records. In real life, these names are going to be harder to guess. And if I can't list them, I'm probably not going to be able to guess them. So when you read about 700 S3 buckets having all their content stolen, implicit in that is that the bad guys got access to list. And list is a devastating thing for bad guys to get access to, in part because there are commands like the following. S3 sync. This is literally quoted from a Department of Justice document describing one of these major breaches. They use the term, the fourth command executed by the hacker was sync. Well, sync is not an API call in AWS. Sync is only an AWS command line interface command. And it's a convenience command. And I can do something like this. I can say from S3, if I can type properly. Right, so there's my from, and I can say to. Now this happens to be in the same, I'm sorry, it's what, 9, almost 10 o'clock in the evening East Coast time, so my typing's a little shabby. But I'm going to take everything from important records, and I'm going to copy it to all your base. Now, all your base is another bucket in this same account, in this case. In the real world, this would be something probably in my own AWS account, right? I would not be transferring it just to another bucket in the same AWS account. I'm doing that for demonstration purposes. But what this sync command is going to do is leverage the amazing power of S3 to very, very rapidly move data in parallelized fashion between different locations in S3. So I just stole all your data. Now, these happen to be just some photographs I took while on vacation, and there are only a handful of them. However, that could be 10 million records in that S3 bucket, and sync would copy those dutifully without any of the packets traversing any of your VPC boundaries. So any kind of TCP IP based notifications or monitoring are not going to help you here. This all happened on the AWS data backplane behind the APIs. I'll point out that not only could we list these buckets, and by the way, these are separate IAM permissions to be able to list buckets and to be able to list the objects within buckets, but sync is dependent on the ability to list the objects within the buckets in order to enumerate them, to steal them. So you don't want anything in your production infrastructure with permission to do lists either of the buckets or of the contents of the buckets. Oh, got, why does my chat keep going away? Okay, cool. So one of our attendees asked, so was the replace association possible because some access was not configured at all, or was it misconfigured? That, I was hoping somebody would ask this. That's a great question. So I'm going to jump over to the AWS console here. Are folks still seeing my screen? Drew, are you seeing my screen?
Yes, indeed.
Yep.
Okay, cool, cool. So let's go take a look at IAM. And in particular, let's take a look at IAM as it relates to EC2. So let me make my font a little bigger here so you can read it. Let's make a new policy. Let's create a policy that is focused on EC2. Where is it? Probably all there, way down there. Okay. Now, I'm going to start from the bottom here. What we're doing here, if you're not familiar with this, is I'm creating a policy that grants access to some kinds of, to certain EC2 commands. So those are called permissions. And one set of those are permissions management. So this is a pretty reasonable list, like create network interface permission, delete network interface permission, modify snapshot attribute. I mean, these are fairly straightforward, and there's only, what, 5 of them. But as I keep going, there are a fair amount more. That's just right. Okay, so if I select this, there are 5. If I select this, there are 258 more. If I select tagging, only 2 more. But if I select read, 17, and list is 111. So what AWS very responsibly and correctly tells you when you go to build an IAM policy to attach to a role to use in your infrastructure environment, they say, always use least permissive. You have a lot of selections here. And so it is quite rare, in my experience, when you start thinking about, I mean, these are very, very granular. People start using stars. They start using wildcards on their IAM permissions. And that is how you get in trouble. The sheer number of these and the fact that they are not just, they don't just have interdependencies within the EC2, they have interdependencies across different services. So this is just for EC2. There are over 100 AWS services. All of them have big piles of IAM permissions. So it is extraordinarily, it's kind of like saying do least permissive is kind of like saying, make sure you never make an error when driving your car on the highway. It's good advice, but it is extraordinarily difficult to actually pull off. And that's how people get in trouble. And that, by the way, is why every time somebody hits the news with a data breach or something else in cloud, I feel bad for them, because this is actually quite daunting. Now at Fugue, we have all kinds of policies written using Open Policy Agent to help tell you if you're vulnerable to the things the bad guys are actually doing. But it is, I don't want to trivialize the problem. It's a serious problem, and that's why we exist as a company. Okay, I've got another question. Excuse me, from Peter to everyone. Hi, Josh. How can you create a policy that has write access to a specific bucket, but not be able to list all the buckets? Excuse me. That's a great question. Let's change services here to S3. Actually, we're about to do a class that is going to be dedicated to building secure S3. So you can see here that list permissions and read and write permissions are separate in S3. So you have the ability to grant the ability to do things like put object, but not the ability to list all my buckets, list bucket, or do reads against the contents of that bucket. So it can be done. It's in there. It's not necessarily the most obvious thing, but it definitely can be done. And Peter, I'm sure Drew and Sivia will reach back out to everyone in this group. We're actually going to do a very dedicated session on building like really secure S3 stuff. All right, that's kind of the end of my scripted demo, if you will. I'll do one more cool nerd background. Okay, this is one that's near and dear to me. And I'm going to stop sharing. So you've got to name the computer. I'm showing my age here because a lot of the stuff is like 90s. But if you can name this computer, it's not System 7. Oh, that's a good guess. Yes, Kevin. Did you already win one, Kevin? Oh, Kevin already won one. Oh, man. All right, Ping gets it. Kevin told me it says it on the screen. Okay, that's a moderator fail. It is Amiga DOS from the old Commodore Amiga days. So anyway, folks, that's what we had. If you have any other questions, fire them over. And Ping, I'm glad this was fun. We try to have fun. Life's not worth living if it's not fun. But if you have any other questions or comments, fire them our way. Otherwise, thanks very much.
Do you have any other backgrounds to challenge them with?
Oh, let's see.
See if there's a good one in there.
Something in here. Let's try this one. That's seriously old school. Now, this is role-playing game stuff, not computer stuff. And all you have to do is name the role-playing game. Old school pen and paper role-playing game. Ping, you can't win twice, man. We told you. Or lady, I don't know. Oh, no takers. Okay. Yeah, it is from the very first version. I mean, Ping, you kind of blew it, man. But it's from the very first. Like a door. Yep. No, we don't do that. But I mean, this is a form of social distancing here. I just want to point out this guy is shooting people with magical spells to keep them from coming close to him, to keep everyone safe from the pandemic. So, all right, folks, I think that's going to be it. Thanks very much for your time and having fun with us this evening. Reach out to us if you want to try out Fugue. It's free. You can use it on your accounts, and we'll tell you about some threats and vulnerabilities. And we hope to be back sometime. Thank you.
Thank you very much, Josh. That was very good. Thank you, Sylvia, for bringing Josh.
Thanks, everybody.
Cool. Thanks much.
You are most welcome. And we will send out your goodies by, you should get them next week.